Welcome to Lesson 1, a review on exponents. Over here we have a quick example of 13 to the 5th power. 13 is the base. That's the number that is being repeatedly multiplied. 5 is the exponent. That tells us how many times to multiply the base. And over here, this is expanded form. And that is where we write 13 to the 5th power as 13 times 13 times 13 times 13 times 13. The actual value of this exponent is 371,293, and you can see that whether I put it into the calculator in exponential form or in expanded form, I get the same answer. The number also gets really large really quickly when we have an exponent. So now let's really quickly complete this table where we go from exponential form to expanded form and vice versa. If we have 3 times 3 times 3 times 3, my base is 3. It is being repeatedly multiplied 4 times. 5 to the 2nd power means 5 times 5. 5 multiplied 2 times. We have x. We don't need to have a number. We have 7 x's, so that's x to the 7th power. Y to the 3rd power would be y times y times y. And then x times y squared, most simply, would be x times y times x times y. And obviously we can continue to get more complicated with how we include exponents, but that is the basics of what an exponent means. I do want to talk about a common misconception. 5 to the 2nd power, for example, is not equal to 10. That would be like 5 times 2. But we're not multiplying 5 times 2. We're multiplying 5 times 5 2 times. Let's continue on to this next example. Now, I'm not sure if both Claire and Tyler have realistic expectations for how much money they're going to save on their summer job. But Claire plans to save $5 per week, and she's working for 10 weeks. Tyler wants to save $2 the first and second weeks, and then double how much he saves each week. So $4 in the third week and $8 in the fourth week. Although it looks here like he just saves $2 for the first week. So I'm going to cross that out. I think that's a textbook mistake. He saves $2 the first week and doubles that the second week to 4, doubles that to 8, etc. So now let's see what each kid saves during their summer job. Claire. Oh no, I'm sorry. I take that back. It is not a textbook mistake. He saves $2 each week, and this is going to be the total amount saved. So Claire saves $5 the first week, another 5 the second week, so now she has 10. She saves another 5 the third week, and now she has 15. And if she keeps saving, we'll have 20, 25, 30, 35, 40, 45, 50, and pretty much 5x, where x is the number of weeks that Claire has saved money. Now, Tyler saved $2 the first week, another 2 the second week, but then he saves 4, so now he has 8. And then the next week he's going to save 8, so now he's going to have 16. And then he's going to save 16, so now he'll have 32, 64. We're doubling this number each time. 128, 256, 512, and then 1024. And if you ever played the game 2048, that would come next. And the equation for this is 2 to the x power. 2 to the first power is just 2. 2 to the second power is 4. 2 to the third power is 2 times 2 times 2, which is 8. And so on. So obviously Tyler is going to be saving a lot more money. Although, to be honest, you can't keep doing this. You can't save $1,024 each week and then double that each week. But it was a nice idea. Well, I don't know what happened in real life. Okay, let's keep going on. Now we have example 3. And for example 3, we have to match something from list A to list B and list C. List A is the repeated multiplication, or, haha, interesting, repeated addition. List B is when it's in exponential form, or for the repeated addition is probably in multiplication form. And list C is the actual value of the number. So let's try to do this with color coding. List A is 8 times 8. We have 8 times 8 times 8. That would be 8 to the third power. And I don't see 8 to the third power here. So since it's multiple choice, let me look and see which of these looks like it can be related to 8 to the third power. Now I do know that 2 to the third power equals 8, because 2 times 2 is 8. So, and I also see here that 2 to the third power times 4 to the third power, well, 4 to the second power equals 8, right? So maybe this is related, and we can come check on Desmos. 2 to the third power times 4 to the third power is equal to 512, just like 8 to the third power. And I think what we have here is the 8 is 2 to the third power, and the 8 times 8 is like 4 times 4 times 2 times 2, which is the same thing as 4 to the third power. Interesting, let's keep going. 9 times 27 times 3. Well, I definitely see a lot of 3 as the base. 9 is 3 squared, and 27 is 9 times 3, so 3 to the third power, and 3 is just 1. So I'm going to go with this answer, where we have 9 times 27 times 3. And now we have 10 times 100. Well, 100 is 10 times 10. Or 10 to the second power. So 10 to the second power times 10 is 10 to the third power. Now we have a fourth times a fourth times a half times a half. And we happen to also have only one fraction over here, a half to the fifth power. Well, because a half times a half is a fourth, a half times a half is a fourth, times a half, we've multiplied 5 1/2. Last and interestingly, they gave us repeated addition, which is 3 added 6 times, and that's what multiplication is. And I think the reason they included this is to contrast. Where multiplication is the same thing as repeated addition, exponentiation is repeated multiplication. Now I forgot to include list C, so let's go through and do that. 8 times 8 times 8, we already looked on the calculator, that's 512. My fraction over here is very likely to match my fraction over here. My 10 to the third power is easy to say, 1,000. And 6 times 3 is 18, which makes me not have to do that really hard multiplication of 9 times 27 times 3, because that's the only option left. And that's all for this lesson. Please feel free to come and ask questions if there's something that you are still trying to work out and make sense of.